Assalamualaikum warahmatullahi wabarakatuh and good day. So in this video, we will discuss example 6.9 which use the method of transformation as well. Okay. So in example 5.19, we consider a random variable y1, the proportion of impurities in a chemical sample. And y2 is the proportion of type 1 impurities among all impurities in the sample. And the joint density function was given this one. So you can see that we have 2 times 1 minus y1, and then your y1 is between 0 and 1, and then y2 is between 0 and 1 as well. And then here we are interested in u equal with y1 times y2, which is the proportion of type 1 impurities in the sample. And then find the probability density function for u. So we want to find small fu, the density function, and then use this one to find the expected u. So the solution here, you can see that in this case, we use the same method in previous video, okay? Because we are interested in u equal to y1 times y2, then first you should fix the y1 at the value y1. What is it? Value y1 is between 0 and 1. Okay, that's the first thing that you do because we have bivariate variables here. Okay, so it's difficult to do two-dimensional transformation. That's why we fix one of the value, then we use the univariate transformation. Okay, and think in terms of univariate transformation. Okay, that's been one dimensional transformation. So here you will have u equal to function y2. Okay, because we fix y1, so we only have function y2. So that's why your y1 is small letter and then you have y2. And then we can determine the joint density function for y1 and u. How is it? We let g y1 u. Then from previous video, you can see that we have y1 here. And then this one actually based on your y2. Okay, because we have u equal with y1, y2. So you can see that here when you have y2, okay, when you have y2, you will get y2 equal with u over y1. Okay, and then this is your inverse function of u. And then this one, when you differentiate this one, you get 1 over y. 1 over y1. Okay, so this one when you differentiate, you get this one. And then this one actually you get from here. Okay, what is your y1? So you will get this one lah. Okay, 2, 1 minus y1. Okay, and then 0 elsewhere. Right? And then when you, this one equivalent to it, when you simplify, okay, when you simplify all this, okay, remember this one, your y1 is fixed from 0 until 1, okay, but here you have u because we've done for u as well here, so you will have u, y1 bring to the left, y1 here, so you can see u less than y1, so that's why you will have this limit. Okay, all right, now u also range between 0 and 1, so you can see that u here is between 0 and 1 as well, but y1 always greater than or equal with u. Okay, now you can find the marginal density function of u, okay, from previous video. So you will have this density function, this function inside here, the joint function of y1 and u, and then you will integrate with respect with y1, okay, because we only have y1 there. All right, so when you integrate here, you can see that y1 is between u and 1, so that's why the limit is u and 1. And then here is the density function, the joint density function, this one. All right, all this, and then you integrate. Okay, so for u is between, and then u is between 0 and 1. Okay, so for this one for y1, okay, and then for u 0, 1, this one you differentiate first lah. Okay, you not differentiate, you integrate, sorry, you integrate. Okay, so you can bring out 2 here. Okay, and then this one you integrate, this one you can simplify first lah. Okay, this one for sure you can simplify, actually you get 1 minus y1, and then you have 1 over y1, isn't it? So when you simplify this one, you get 1 over y1 minus this one, actually y1 over y1, you get 1. All right, so that's why you have this one. Okay, and then you integrate with respect with y1, so this one you will get 1 over y1, you can get ln y1. Okay, integrate this one. If you remember, okay, we have when you integrate or 1 over y1, you get ln y1. When you differentiate ln y1, you get 1 over y1. This one you must remember. When you have ln x, you differentiate, you get 1 over x. When you have 1 over x, when you integrate this one, you will get ln x. All right, that's why here you have ln y1. And then your y1 is between u and 1. And then here when you integrate 1, you get y1. So again, similar from u until 1. Then you simplify, you substitute the value, you will get 2 times negative ln u minus 1 plus u. You simplify, then you get this answer. Okay, then you will get the marginal density function of u will be this one. Okay, again the symbol ln to stand for ln. All right, so similar for this example, the step, okay, first study, you let one of the variable is fixed, okay, and then you use the other variable to do the transformation, okay, and then find the joint density function for the fixed y you choose to with u, okay, by using this one, okay, and then you find the marginal density function of fu. All right, and then use you don't forget to do the limit as well, this one, and here finally you have here. Okay, so you integrate y1 because this is the marginal density function, and then you simplify, you substitute the value, then you get the density function of u. Okay, so that's the main objective of this question. Once you get the density function of u, you need to find the expected u. Okay, again here expected u, you know, you've learned before in previous chapter, you will have u fu du. So here your u is this one, and then your fu is from here. All right, then you simplify here, you will get 3 terms. First term, second term, and third term, because you have here. All right, easier for you to do this. And then your u is between 0 and 1. So this one is easier. Okay, u cube over 3, integrate 0 to 1. And here you can use integration by part. This one, okay, this is how they show you. Actually, integration by parts we have done before in bridging class and in previous education. Okay, and then this one also easier lah. All right, then you substitute the value. Finally, you get the expected u is 1 over 6. All right, so this answer agrees with the example 5.21, whereas your expected u is equal with this one was found by different method. All right, that one you can check. Okay, important here, you should know how the transformation method works. Okay, so this is the summary of the transformation method. So first, let u equal to a function of y, and then y, the function of y to either increasing or decreasing function of y, but the density function of y is greater than 0. Okay, and then first, what should you do? Find the inverse function of y, which is inverse function u, okay, and then you differentiate, okay, this one, and then you can find the density function by using this concept. All right, so this one also applicable for the bivariate random variable just now lah. Okay, from the previous example and the previous video. All right, so please try exercise question and then look either you understand or not, and then if you find any difficulties or any question, you can ask me. Thank you, class.